Okay, here it is, the moment we've all been waiting for. You know how I said you couldn't take the square root of negative numbers? Surprise! You can. So let's talk about complex numbers, which are the square roots of negative numbers. So if a and b are real number, then any number of the form a plus bi is a complex number, where a is the real part and b is the imaginary part. And I is the square root of negative 1. So the imaginary unit I is defined as I equals the square root of negative 1. And so if you were to square that, you would get I squared is negative 1. This is like one key takeaway. Remember that I squared is negative 1. So I is the principal square root of negative 1. For any positive number b, if I'm taking the square root of a negative, what I'm going to do is I'm going to pull that number out. I'm going to pull out I, right? So if I had the square root of negative 8, that's the same as the square root of negative 1 times the square root of 8. We're pulling it apart, and that would give me I squared of 8, which, yes, I know I could simplify. Okay, let's do it. That's 2I squared root of 2. So you always want to pull out the imaginary part first. So if I have the square root of negative 100, that's I squared of 100, which is 10I. I we kind of treat like a variable. It always comes second. If I have negative square root of negative 36, that's going to be a negative 6I. If I have the square root of negative 2, that's I square root of 2. And if I have the square root of 54, first of all, I need to factor 54. Oof, that's 2 times 27. 27 is 9 times 3. 3. Okay. So I have to pull out an I, right? Then my only duplicate is a 3, so that's going to come out. So I have 3I square root of 6. So it's just an extra step in our simplification process, and we would go real number part, imaginary, and then radical goes last. So let's do some operations with radicals. We kind of treat them like variables until it comes to multiplication. So when we're adding and subtracting, if I have 2 plus 3i plus 6 plus 4i, I add my real parts, which is 8. 3i and 4i is 7i. That doesn't look like a 7 now, does it? Okay, if I'm subtracting, remember I have to distribute that negative. So I've got 6 plus 5i minus 3 minus 2i. 6 minus 3 is 3. 5i minus 2i is 3i. For problem 4, I've got 4 plus 2i plus 3 minus I plus a negative 6, so minus 6 plus 3i. And we combine like terms. So I've got 4 plus 3, which is 7, minus 6, which is 1. 2i minus I is I, plus 3i is 4i. So I have 1 plus 4i. Last example, again, we've got to distribute the negative. 7 minus 3i minus 8 plus 6i, because 2 negatives make a positive. 7 minus 8 is a negative 1. Negative 3i plus 6i is a positive 3i. So that's how we go about adding and subtracting complex numbers. Treat them kind of like variables. You just combine the like terms. When it comes to multiplying complex radicals, the first thing you have to do is pull out the I. And you always need to remember that I squared is negative 1. So let's take a look at this. I have the square root of negative 4, which is 2i, times the square root of negative 9, which is 3i. So I get 2 times 2, which is 6. I times I is I squared. Well, I squared is negative 1. My final answer is negative 6. Let's try this again. I've got I squared root of 3 times I squared root of 7. This would give me I squared times the square root of 21. I squared is negative 1, so I just have negative square root of 21. And you can see that if I didn't pull the I out first, I wouldn't have the correct answer, right? If I just went ahead and multiplied those, I'd have the square root of a positive 21, which is not the case. So I have I square root of 2 times 2I square root of 2. So I have 2I squared square root of 4. So I have 2 times negative 1 times 2, which gives me negative 4 for my final answer. If I have negative 5 times the square root of 6, that's the I square root of 5 times the square root of 6. So I have I square root of 30, which can't be simplified any further.